Algebra 2, Chapter 10, Test Review, Rational Expressions and Equations. We're going to be having a test early next week over rational expressions and equations, so this study guide is going to be very helpful with this. So we're just going to go over these problems, and I invite the viewer to pause at any time and work out the problem, then roll ahead to see if you got it right. Okay, problem 1. We have here, it says list any excluded values to the rational expression x minus 2 over 10x squared minus 40x. To find the excluded values, what we have in play here is the principle that division by 0 is not defined in math or in algebra. So if we set our denominator to not equal to 0, sometimes people like to set it equal to 0. I like to set it to not equal to 0 to remind us that we're looking for excluded values. And we're going to factor this denominator to help us isolate the excluded values. And between these two terms, the common factor is going to be 10x. And so if we take 10x times what equals 10x squared, well, that's going to be x. And 10x times what equals negative 40x, well, that's going to be negative 4. And we can tell if we're right, because if we multiply, distribute back together, we're going to find what we have here. So we have the zero factor or zero product property. So 10x cannot equal 0, and that's what the zero factor or zero product property is. Anything times 0 is 0. And also x minus 4 cannot equal 0. So therefore, we have here that x cannot equal 0, nor, adding 4 to both sides of this inequality, x also cannot equal 4. So for our excluded values, we would have x cannot equal, I'll put in set notation 0, 4. Okay, next, problem 2. What are excluded values to this rational expression? X squared minus 9 over x squared minus 4x minus 12. And again, as number 1, we set our denominator, x squared minus 4x minus 12, to not equal to 0, and then factoring, and I hope this is factorable. I'm not sure that it is yet. So we know that the factors of x squared are x and x. I know we have minus 12, so that's going to be a minus times a plus. And now what two numbers multiply together equal 12, but whose difference is 4? Well, that's going to be 6 and 2. So now it remains a matter of finding which the 6 goes where, the 2 goes where. Well, this minus 4 is bigger, and so you need to have your 6 minus, because for this is minus, your biggest number has to be negative. So you have minus 6 times x, quantity x plus 2. So x minus 6 cannot equal 0, nor can x plus 2 equal 0. So x cannot equal 6, nor can x equal negative 2. So excluded values, I'm just going to abbreviate here, excluded, we would say x cannot equal, in set notation, negative 2, 6. Okay, let's go ahead to number 3. Write 3x plus 9 over x minus 4 as an equivalent rational expression that has a denominator of x minus 4 times x plus 5. So we have, I'm going to rewrite this 3x plus 9 over x minus 4, And what can we do to this denominator to get this x minus 4 times quantity x plus 5? Well, we have to multiply our denominator by x plus 5. But to preserve the same value of this expression, we need to do likewise to the numerator, which is multiplied by quantity x plus 5. And then if we do that, what do we have to do to this 3x plus 9? Well, we have to parenthesize the 3x plus 9, make it quantity 3x plus 9. And now in the numerator we can expand or do whatever we want, but at this point we have an equivalent expression, and that is our answer to number 3. Now, number 4, we have write 3x cubed over 3x minus 6 as an equivalent rational expression that has a denominator of quantity 2 minus x times quantity x squared plus 9. So let's go ahead and rewrite this original expression 3x cubed over 3x minus 6. But before I do that, let me go ahead and take this 3x minus 6 and see if that is factorable. Well, that's going to be 3 times quantity x minus 2. So I'm going to rewrite this denominator over here as 3 times quantity x minus 2. So what we want to do is we want to go ahead and get this as 2 minus x. But we want this denominator that doesn't have a 3 in it. So I'm going to take advantage of noticing that 3 over 3 will cancel. And so now we have an equivalent expression of x cubed over x minus quantity x minus 2. But I want this to be 2 minus x instead. That's what I want it to be. So what I have to do for that, I can get 2 minus x here if I take a negative sign, factor out a negative sign from this x minus 2. So if I factor out a negative sign, I get x cubed over negative. Now I can write this as 2 minus x. Can you see if we redistribute the negative sign, we're going to get x minus 2 up here? So I'm going to just work to the right here to preserve room. So I'm going to go ahead and take this negative sign and move it up to the numerator, since we don't want to have a negative sign in this denominator. So in fact I have an arrow here. I'm just going to write this as negative x cubed over 2 minus x. And now the last thing we're going to need to do to get our denominator, our target denominator, is to multiply that denominator of quantity 2 minus x by quantity x squared plus 9. And now, having multiplied the denominator by quantity x squared plus 9, we need to likewise multiply the numerator by the same thing to preserve the value of the expression. So now we have rewritten this original expression as shown below, and we can check these denominators. They are the same, and so this is going to be our equivalent rational expression with the target denominator. Let's go on to number 5. What is the most simplified form of a rational expression? They give this rational expression here, and to simplify rational expressions, one thing that's very helpful is factoring where we can. And so first for the numerator, I'm going to write this over here at the right. We have x squared minus x minus 20, and that's going to factor into, we have x and x, and we have minus 20, so that's going to be a plus times a minus. And then it looks like we have minus x, so that's going to be 4 and 5. So it's going to be minus 5 and x plus 4. If we multiply these back together again, we see that we have x squared minus x minus 20. And now for the denominator, that x plus 1, we probably can't do anything with that. Let's take this quantity x squared minus 16, and what we have here is a difference of squares. So what we do is, for difference of squares, we have the square root of x squared, which is x and x, and we have plus, minus, and what is the square root of 16? 4. So 4, 4. So now we can rewrite this whole expression with our rewritten numerator, quantity x plus 4 times quantity x minus 5 over our rewritten denominator. We have in place of x squared minus 16, we have quantity x plus 4, quantity x minus 4, and we bring down this x plus 1. And we cancel where we can, and I think the only thing I see that is cancelable is this x plus 4 over x plus 4. And so our simplified rational expression is, we have in the numerator x minus 5, and we don't have anything to multiply this x minus 5 by, so we can just leave that in the numerator without parentheses. In the denominator we have quantity x minus 4 times quantity x plus 1, and so that should be our most simplified form of this rational expression. Next, we have a question. Are x minus 3 over quantity x plus 4 times quantity x minus 6 and 3 minus x over quantity 4 plus x, it's 6 minus x, equivalent rational expressions? Well, let's check this out. Now, what I notice here is that I think we have some sign differences. So what I'm going to try to do is work with this first one here to see if I can get this like the second one. So in the numerator, if we take this x minus 3 and multiply it by negative 1, and if this works out right, we're going to have to take this denominator, quantity x plus 4, x minus 6. If we multiply this numerator by negative 1, we have to likewise multiply the denominator by negative 1. Well, okay, I'm going to go ahead and work down here. What we have here is we're going to have negative 1 times quantity x minus 3 is going to be, we can write this as 3 minus x. And in the denominator, now in the denominator we have to choose, can distribute this negative 1 to only one of these factors here. So I'm going to take this, I'm going to distribute it to this x minus 6, and we distribute the negative 1 to that, we're going to get x, we're going to get 6 minus x. And then the last thing we do is we have this original expression on the left is x plus 4, but we want 4 plus x. And because of the commutative property of addition, doesn't matter which order we add things in, so we can rewrite this 4 plus x. So we should be able to see at this point that we have an exactly equivalent rational expression, and so this is correct. Now, should you have a graphing calculator in hand, you can also check for equivalency by graphing each of these functions and further looking where the graph is, looking at the table view, seeing that they are equivalent. So that's another way of verifying your correct answer. Next, 7. Add or subtract the following rational expression to get one simplified fraction with a single denominator. State any excluded values. Well, if we look at these as we have x minus 2 over plus 5 over quantity x minus 4. So our common denominator for this, and you can kind of think this is x over 1 minus 2 over 1. If you multiply the denominators together, you're going to get a denominator x minus 4. So what we're going to do is we're going to take this x, and what do we have to multiply the denominator by to get x minus 4? It's just going to be x minus 4. But if we did that in the denominator, we have to likewise do that in the numerator. So we have common denominarized, if you want to call it that, this first term here of x. Next we take this minus 2, and we're going to have to divide by x minus 4, and we place x minus 4 in the denominator. What do we have to do in the numerator? Also multiply by x minus 4. And then we have plus 5, and we don't have to do anything. We're just going to put x minus 4, and do we have to do anything to this numerator to get the common denominator? No. So now we can distribute and place all of these under one denominator, or over one denominator. So I'm just going to make this over x minus 4. Now we have to be kind of careful with our signs as we go across. Well, we have, first of all, we have x squared minus 4 times x. And then the next one we have minus 2 times x. And we have minus 2 times negative 4. Well, that's going to be a negative negative, so that's going to be plus 8. And the last thing we have is this plus 5. And so now we can go ahead and combine our like terms. So we have x squared. So we have minus 4x minus 2x is going to be minus 6x. And then we have 8 plus 5 is going to be plus 13 over x minus 4. Now it says that the last thing here is state any excluded values. Well, for excluded values, since x, denominator x minus 4 cannot equal 0, x therefore cannot equal 4. So we have our one simplified fraction, and we have our excluded value, which is 4. Next, 8. Okay, same instruction, but we have a different problem here. So we have our 2 2x over x squared plus 7x plus 12 minus 4 over x squared plus 8x plus 15. So let's go ahead and see if we can factor these denominators to get help with what we're doing here. We got x squared plus 7x plus 12, and that's going to be equal to what two numbers? Okay, we have x, and everything's plus. We got plus plus. What two numbers multiplied together are 12, but added together are 7? Well, they're going to be 3 and 4. And now for the next denominator, we have x squared plus 8x plus 15. And what does that factor to? Okay, again, we're going to have x and plus plus. So what two numbers multiplied together are 15 but added together are 8? Well, they're going to be 3 and 5. And so for our common denominator between all these, what we're going to have is we're going to have quantity x plus 3, which is common to both of those original denominators. And then we're going to have x plus 4 times quantity x plus 5. So let's go ahead and work this out. So we have 2x, and now I'm going to write this as over quantity x plus 3 times quantity x plus 4 times quantity x plus 5, or times quantity x plus 5. And then what do we have to multiply our numerator by to work this out? Well, originally, as you recall, we have this first one, x squared plus 7x plus 12. That's x plus quantity x plus 3 times quantity x plus 4. So to what we're bringing in to the common denominator, we need to go ahead and multiply by x plus 5 to preserve that. So we have x plus 5. And then we have minus 4. And then our original denominator is this second one here, which is quantity x plus 3 times quantity x plus 5. And what is missing from this? Well, our x plus 4. So now we have x plus 4. But we have to likewise multiply our numerator by quantity x plus 4. And so now we have two fractions with a common denominator. And so we can simplify this, or distribute. So we get 2x squared plus 5 times 2x, which is going to be 10x. And then we're going to have minus 4x, and that's going to be minus 4 times 4, so that's going to be minus 16. And that's going to be all over this quantity x plus 3, quantity x plus 4, times quantity x plus 5. And lastly, what we have here is we can combine like terms in the numerator. So the only thing we can do there is take that 2x squared, and then we have 10x minus 4x, so we have this going to be plus 6x, and then we have minus 16 all over our common denominator of quantity x plus 3 times quantity x plus 4 times quantity x plus 5. And then it says for excluded values, let me do that. By the way, this is going to be our answer here, excluded values. Well, in the factored form, we have x plus 3, x plus 4, x plus 5. So x cannot equal negative 3, x cannot equal negative 4, and also x cannot equal negative 5. So those will be our excluded values. Next problem, 9, same instructions. Add or subtract the following rational expression. And here we have three fractions subtracted. We have one subtraction, one addition. So the only thing I can see to factor here is this x squared minus 16 in the middle term. And that's going to be factored using different squares to quantity x plus 4 times quantity x minus 4. So this is going to be our common denominator is going to be quantity x plus 4 times quantity x minus 4. Okay, let's rewrite this original fraction. So we have this 3 over x plus 4. And what do we have to multiply this by to get our common denominator? We have to multiply this by quantity x minus 4. And since we multiplied our denominator by quantity x minus 4, what do we have to do in the numerator? Also multiply by quantity x minus 4. And then we have minus 7 times, I'm going to rewrite this denominator in its now factored form, quantity x plus 4 times quantity x minus 4. And then what do we have to multiply this by to get our common denominator? Nothing. So I'll just leave that blank. And then the last fraction we have is plus. We have 2x over x minus 4. And what do we have to multiply this x minus 4 by? X plus 4. And likewise, I multiply the numerator by quantity x plus 4. And so now we have these three fractions written with the same denominator. So what we have here is I'm going to distribute here 3x minus 12. Then we have minus 7. And then we have 2x times x. It's going to be 2x squared. And 2x times 4 is going to be plus 8x. And that's going to be all over our common denominator. And I'm just going to leave this in the factored form of quantity x plus 4 times quantity x minus 4. And then the last line here, we should be able to combine all these terms. Well, we have 2x squared. And what about the x's? Well, we're going to have 3x plus 8x. That's going to be plus 11x. And next we have negative 12 minus 7. That's going to be minus 19. And that does not look, my friends, at all factorable. Then we have quantity x plus 4 times quantity x minus 4. And so that will be our simplified fraction with a single denominator. And next, for excluded values, okay, what we have is x cannot equal, I'll just write it like this, plus or minus 4. So that would be those would be our excluded values. Next, let's go on to 10. Find the excluded values to the quotient. Quantity x minus 2 times quantity x squared minus 49 over x squared minus 16 divided by 5x minus 40 over 5x. Well, what we're going to do when you divide divide a fraction by another fraction, what that's going to be, it's going to be equivalent to what I'm showing you here. Quantity x minus 2 times x squared minus 49. And so the main technique here is to change a division problem into a multiplication problem by multiplying by the reciprocal of what we're dividing by over here. So we're going to turn this upside down, and then we have over 5x minus 40. Now, in finding excluded values, we have to concern ourselves with both the original expression up here on top and the one below. So in the one on top, we have x squared minus 16 cannot equal to 0, and so that's going to be quantity x plus 4 times quantity x minus 4 cannot equal 0. So I'm going to put down below kind of excluded values right below. So x cannot equal plus or minus 4. So those are two excluded values. And next, we're going to take our original denominator of this second fraction. So 5x cannot equal 0. So therefore, x cannot equal 0. I'm going to write this down here in the summary statement. X cannot equal 0. Now, one more thing we have to concern ourselves with is this, is when we went ahead and changed the original problem to a multiplication problem, we have to take what now is our denominator for this second fraction. So we also have 5x minus 40 cannot equal 0. And so factored, that's going to be 5 times quantity 8, x minus 8 cannot equal 0. So that's going to be x minus 8 cannot equal 0. So x cannot equal 8. So this is going to be our final excluded value here. X cannot equal 8. Now occasionally you'll see people try to take in the dividend, in this case what I'm circling up here, they'll try to go ahead and factor that out and include those exclusions in the family of excluded values. But that's not, we can actually have this numerator here that I've circled be 0. So these would be our total number of excluded values: 4, plus or minus 4, 0, and 8. Okay, here we have a problem 11 to 14. Find the product or quotient as indicated and list any excluded values. Well, what we're going to do is take our we're going to try to factor everything we can. So this numerator, we have x squared minus 4x minus 5. And what we're trying to do, what we're hopeful of doing, is finding in factored form a lot of opportunities for cancellations. So our numerator here, x squared minus 4x minus 5, the factored form of that's going to be x and x. And we're going to have minus 5, so that's going to be minus plus. And so our factors of 5 are pretty much going to be 5 and 1. And we have minus 4x, so that's going to be minus 5 and plus 1. Okay, that's going to be factored form of that numerator. And then the next one, we're going to have our denominator 3x minus 15 And in factored form, that's going to be 3 times quantity x minus 5. So when it comes to excluded values here, I'm going to write this down here. Kind of pick those up as we go. We have x cannot equal 5. And why do we know that? Because x minus 5 cannot equal 0, so therefore x cannot equal 5. Okay, and then the last denominator we have to work with here on the right is going to be x squared minus 2x minus 3. And what is that in factored form going to be? That's going to be x and x, and we have minus 3, so that's going to be a plus and minus. And I think it's going to have to be minus 3 here. And then this is going to have to be 1 here. And so what we're going to have here is that x plus 1 cannot equal 0, and x minus 3 cannot equal 0. So x cannot equal negative 1, and x cannot equal 3. So these would be our excluded values. And now let's go ahead and rewrite this whole fraction here. The numerator we rewrite is quantity x minus 5 times quantity x plus 1. And then we divide that by 3 times quantity x minus 5. I'm just reading off the factoring at the right here as I go along, times 4 over what is our second denominator in factored form? Well, it's going to be quantity x plus 1 times quantity x minus 3. So we're going to multiply straight across, and what I like to do for this technique sometimes, if we've written it, we can just go ahead and put a bridge over that multiplication dot, and we can just cancel where we see the opportunity to cancel. So we have x minus 5 over x minus 5 will cancel each other out, and likewise x plus 1 over x plus 1 will cancel each other out. So we write what we have left, which is 4 in the numerator over 3 times quantity x minus 3. And so this will be our product. It says product or quotient. This is our product, and is our answer, and we have our excluded values. Next, problem 12. We have x plus 2 over x minus 4 divided by x times, or divided by 3x minus 12. So what I'm going to do for this is, let me go ahead and factor out that second denominator. So 3x minus 12 in factored form is going to be 3 times quantity x minus 4. And let's talk about excluded values here. And I like to really, a lot of times, do excluded values right after factoring to make sure we keep this straight. So excluded values, we know that x minus 4 cannot equal 0, and so x cannot equal 4. And then what we have is what else do we have? Yeah, in this next one here, we also have 3 times quantity x minus 4 cannot equal 0, but we've already figured out that x cannot equal 4. But when we rewrite this as a multiplication problem, we're going to take x plus 2 over x minus 4, and dividing by a fraction is the same as multiplying by its reciprocal. So we take this one right here. I'm going to rewrite this 3x minus 12 as 3 times quantity x minus 4, and then this x goes down here. So we also, for excluded values, now have x cannot equal 0. So that's going to be right here to our list. So it looks like we only have two excluded values here. X cannot equal 4, nor can x equal 0. And now let's go ahead and, having multiplied, I'm going to go ahead and bridge. And when we bridge the division bars, we're going to parenthesize everything here and cancel where we can. Well, the only thing I can really see to cancel is this x minus 4 over x minus 4. And so what that's going to leave us with is 3 times quantity x plus 2 over x. And I don't see any way to simplify this further, so that's going to be our quotient in this case for problem number 12. Next, problem 13. We have x plus 3 over x plus 2 times 2x minus 4 over x squared minus 9. So I'm going to write this as a multiplication problem, which it is, x plus 2. And let's go ahead and factor what we can. And so for our second fraction here, 2x minus 4 is equal to 2 times quantity x minus 2. And in the denominator, this x squared minus 9 is going to be equal to our difference of squares version, which is going to be x plus 3 times quantity x minus 3. So our excluded values are going to be found by looking at what we cannot divide by. It's x. We cannot divide by 0. So x minus 2 cannot equal 0. So for our excluded values, which I'm writing over here, we have x cannot equal 2. That's excluded. Okay, and then also we have quantity x plus 3 times quantity x minus 3 oops, I think I got this wrong here. Okay, we're talking about this. For finding excluded values, we got to take this x plus 2. This one on top does not count. Okay, we didn't, so we have x plus 2 cannot equal 0. So therefore x cannot equal not 2, but x cannot equal negative 2. Okay, there we go. And now getting back to this x plus 3x minus 3 cannot equal 0. So x also cannot equal plus or minus 3. So those will be our excluded values. Now let's go ahead and rewrite this up here. We got here the second fraction, we got 2 times quantity x minus 2, and then we have over, we have x plus 3, x minus 3, and then we can bridge our fractions and parenthesize what we need to, and cancel where we can. Well, I see x plus 3 over x plus 3 canceling, but I don't see anything else to cancel here. So what we're going to have for our answer here is I'm going to leave the numerator here in place, 2 times quantity x minus 2 over quantity x plus 2 times quantity x minus 3. And so that's going to be our product. I want to go back here to this one here, make sure I got this right. Yeah, that's right. Okay, next, problem 14, we have a division problem, and we're going to take x minus 3 over x minus 4. We're just going to bring that over, and dividing by x minus 2 over x squared minus 16 is going to be the same as multiplying by its reciprocal, which is x squared minus 16 over x minus 2. So the only thing I can see to factor here is this x squared minus 16 is going to factor into quantity x plus 4 times quantity x minus 4. And let me write this below. We have x minus 3 over x minus 4, and we're going to multiply by quantity x plus 4 times quantity x minus 4 over x minus 2. So that's factored form. And now for excluded values, we know that x, set our first denominator, we know that x minus 4 cannot equal 0. So for excluded values, that's going to be x cannot equal 4. And the next thing we have is this x squared minus 16, which is going to be x plus 4, x minus 4. So we know x plus 4 times quantity x minus 4 cannot equal 0. Well, we've already picked up this x cannot equal 4, but also x cannot equal negative 4. And then we have our, when we go ahead and multiply by the reciprocal, we also know that x minus 2 cannot equal 0, so x cannot equal 2. So those are all our excluded values. And now with what's left, we can go ahead and cross our fractions here and put parentheses where we need to and cancel where we can. So I see we have x minus 4 over x minus 4. And is there anything to cancel out this x minus 2 in the denominator? Well, if there is, I don't see it. So what we have left in the numerator is quantity x minus 3 times quantity x plus 4 over x minus 2. And we could go ahead and multiply and expand out and get a quadratic trinomial in standard form, but we don't need to do that, so we're just going to leave it like that. Next, problem 15. Solve the rational equation by completing the table and graphing the results. So let's go ahead and do that. We have input value of we're going to take input values, so I'm going to work these over here on the left. If we go ahead and plug in 0 to this expression here, we'll get 0 minus 1, so we have negative 1. So our point here, or an xy coordinate pair, is going to be 0, comma, negative 1. And next, if we plug in 1, I'm going to work this out here, we're going to get 1 over 2 minus 4 minus 1, which is going to be 2 minus 4 is negative 1/2, so we get negative 1/2 minus 1, which is going to be equal to negative 3/2. So I'll put negative 1.5. So we have 1 comma negative 1.5. Next, if we plug in 1.5, we're going to get 1.5 over 1.5 minus, it's going to be, 1.5 times 2. So 1.5 over 1.5 times 2 is 3, right? 3 minus 4. So what we get is 1.5 over negative 1. We're going to have negative 1.5. Oops, that doesn't look right. Oh, minus 1. Forget that. So we have is minus 1.5 minus 1. It's going to be minus 2.5 or minus 5/2. I'll put minus 2.5 here. And so for this we're going to get 1.5 comma negative 2.5. Okay, and next what we have here is plug in 2.5. So 2.5 over 2x, and that's going to be 2 times 2.5 is going to be 5 minus 4 minus 1. So that's going to be 2.5 over 1 minus 1. So that's going to be 1.5. So we got 1.5 here, and we have coordinate pair 2.5 comma 1.5. And now if we plug in 3, we have 3 over 2 times 3, which is 6, minus 4. That's going to be minus 1. So what we have now is 3 over 2 minus 1. So 3/2 minus 1 is going to be equal to 1/2 or 0.5, or you can put 0.5. That's going to be 0.5. So you got 3 comma 0.5. So that's that point. And now the last one we have is 6. So we're going to get for this one 6 over 2 times 6, or 12. So 12 minus 4 minus 1. So that's going to be equal to 6 minus 12 minus 4 is going to be 8. So we get we get 3/4 minus 1, which equals negative 1/4. So we get negative 0.25. So our coordinate pair here is 6 comma negative 0.25. And now graphing, let's see what we get here. Now we have a denominator here, 2x minus 4. So 2x minus 4 cannot equal 0. And so working to the right here, we have 2 times quantity x minus 2 cannot equal 0. So x minus 2 cannot equal 0. So x cannot equal 2. So 2 becomes, I'm drawing in a dashed vertical line. That's going to be our vertical asymptote. So x equals 2 is our vertical asymptote. That's going to help us as we graph this, I think. Okay, let's go ahead and plot in the points. We have 0, negative 1, which is right here. In fact, I'm going to go ahead and change color. We have 0, negative 1. And the next one we have is 1, negative 1.5. So here we have 1, negative 1.5. Next we have 1.5, negative 2.5. So here's 1.5, and that's going to be negative 2.5. So we have something that looks like this. I'm just connecting here like this. So that's going to be on the left side of our vertical asymptote. Now these other values here we have, to the right we have 2.5, 1.5, so that's going to be right up here. Next we have 3, 0.5, that's going to be right here. And the last one we have here is 6, negative 0.25, so 6, negative 2.25 is going to be like this. So for this one we're going to be looking something like this. And that's going to be it according to the instructions. Let's go ahead. One thing I did before starting this video lesson is I went and put this function here, and when you graph this you will look and see where you have a vertical asymptote at x equals 2, and we see here at, let's see, 1, 2, 3, 4, 5, 6, we have 6, negative 0.25. And so you'll see the points are the same, and you can check them in the table view also, which I'm not going to do right now. Let's see if that came across here. Yeah, it came across pretty well. Oops. That's yeah, all the calculators there. That looks good. Okay, for problems 16 through 18, solve each rational equation algebraically. List any excluded values. Well, I'm going to go ahead and I'm going to get a least common denominator here. Let me go ahead and change colors back again. Okay, least common denominator is going to be quantity x plus 1 times quantity x plus 4. And then as far as excluded values, we cannot divide by 0 in math or in algebra, so x cannot equal negative 1, and also x cannot equal negative 4, because either x equaling negative 1 or negative 4 will make this equation undefined. And so now what we're going to do is multiply each side of this equation by our least common denominator. So we're going to have 5 times quantity x plus 1 times quantity x plus 4 over x plus 1, and that's going to be equal to 2 over, well, we'll say times quantity x plus 1 times quantity x plus 4, and that's going to be all over x plus 4. And now we cancel, so x plus 1 over x plus 1 cancel, and what we have is here x plus 4 over x plus 4 cancel, and so what we have left is 5 times quantity x plus 4 is equal to 2 times quantity x plus 1. Now we're going to distribute and solve this linear equation, we hope. So we get 5x plus 20 is equal to 2x plus 2. And then what I'm going to do is subtract 2x here. And then I'm going to subtract 20 from each side of this equation. So we get on the left side, okay, that will cancel out, and that will cancel out. So we get 3x is equal to 2 minus 20, which is negative 18. So dividing by 3, x is going to be equal to negative 6. And since, okay, this is going to be a real solution, because x equals negative 6 is not an excluded value. Okay. And yeah, we have our excluded values. Okay, let's go on to 17. Okay, let's go ahead and find for our common denominator, for our least common denominator, we're going to have this quantity x plus 1, and then we're going to have times 2x. So what I'm going to do for that is I'm going to put 2, because we have that 2 there. We have, it'd probably look better if I put 2x times x plus 1. So that's going to be our least common denominator. And for excluded values, we know that x plus 1 cannot equal 0. So I'm going to write this down here, excluded values. X cannot equal negative 1. And then also 2x or x cannot equal 0. So I'm going to put, they're going to be the same either way. So I'll put x cannot equal 0. So x cannot equal 0. That's another excluded value. Okay, let's go ahead and work this out. So for the first fraction, we have 3x over x plus 1, and we're going to multiply this fraction by 2x times quantity x plus 1, and then we have plus 6 over 2x, and we multiply this by 2x times quantity x plus 1. And then finally, let me see here, a little more legible here, equals 7 over x. We're going to multiply this by 2x times quantity x plus 1. And then if we have a good denominator, least common denominator, we should be able to cancel out everything we have in each denominator. So in the first fraction, x plus 1 over x plus 1 cancel, 2x over 2x cancel, and x over x cancel. So what we have left is we have 3x times 2x, and then we have plus 6 times quantity x plus 1, and that's going to be equal to 7 times 2, which is 14, quantity x plus 1. And now distributing here, we get 3x times 2x is going to be 6x squared plus 6x plus 6, and then on the right side we have 14x plus 14. And what we're going to do now is set the right side equal to 0 by subtracting 14x and 14 from both sides. We get minus 14x minus 14. So we get 6x squared minus 8x, And 6 minus 14 is going to be negative 8, I believe. Is that right? Yes. Okay, that's going to be equal to 0. And really between this, a common factor is 2. So that's going to be 2 times quantity 3x squared minus 4x minus 4 is equal to 0. I'm not sure how factorable this is, but I'm going to use the x method here. So we're going to put this, we're going to say a is equal to 3, b is equal to negative 4, c is equal to negative 4. So ab up here, 3 times negative 4 is a negative 12, and b is going to be negative 4. So what two numbers, which when multiplied together equal negative 12, but added together equal negative 4? Well, I'm going to think negative 6 and 2. And then we're going to divide this by a, and a is 3. So what we're going to get is, I'm going to write this down here, we're going to have x minus 6 over 3, which is negative 2. So we're going to have x minus 2, and then we have this x, plus 2/3, and if we bottoms up this guy here, that's going to be equivalent, at least for factoring purpose, 3x plus 2. So we have 3x plus 2 is equal to 0. So what we have here is just kind of, I'm just going to kind of work to the right. So we have x minus 2 is equal to 0, and we have 3x plus 2 is equal to 0. So x is equal to 2, and also for this other one we have to subtract 2 and divide by 3, so x is equal to negative 2 over 3. So are any of those excluded values? Okay, these will be both real solutions. And what I did for this problem here is I graphed it earlier. I forgot to show problem 16. Let's go here to 17. Here it is, entered. Let's graph and take a look here. See if we see where they are. I don't see it at all. Oh, I have to go and activate that. Go to that equal sign, press enter. Okay, now it's activated. Let's graph. So we have this one on the left is going to be negative 2/3. X equals negative 2/3, and to the right here x equals 2. Check. So that's checking by graphing. Okay, the last one in this video lesson is problem 18. Same instruction here. So for this one we have our least common denominator, which is our only common denominator, is going to be x minus 8. So we have a least common denominator we can multiply by, and also for excluded values, so excluded value since x minus 8 cannot equal 0, we know that x cannot equal 8. Okay, let's go ahead and work this out. So we have x over x minus 8, and we multiply this by x minus 8. And on the right side we're Well, there's 24 minus 2x. We can factor that out. Let me do that. I'm going to work below here. Let me look below on the left. So 24 minus 2x is going to be equal to negative 2x negative 2x minus 24. Yeah, that's right. That's what we get. So that's going to be equal to negative 2 times x minus 12. So I'm going to, on the right side, write negative 2 times x minus 12. It's just a more familiar looking form for me. And we have over x minus 8, and it's going to be times x minus 8. Okay, and that will cancel there. This will cancel here. And so what we have is x, that's all we have on the left side, x is equal to negative 2x plus 24. And if we add this together, we get, add 2x plus 2x, we get 3x is equal to 24, and we divide by 3, we get x, but this x is equal to 8. Okay, since x equals 8 is an excluded value, then x equals 8 is what we call an extraneous solution and not a real solution. An extraneous solution is a solution that is created, that is not real, in the process of solving the problem. So that's really the whole review. It's quite lengthy, but this is going to be 80-90% of what's on your test. I hope it's been helpful to you. Good luck, and as always, thanks for viewing.